Thanks for joining us here today. We are here to warn the public about the dangers of pharmaceutical drugs in the environment. People all over the world are using these drugs not knowing the harms they can cause. It is important we share with you the dangers of these drugs when they get into the environment so we can avoid these issues from happening. Unfortunately, pharmaceuticals can be found in water, which has potential dangers for many organisms. In rivers and other bodies of water, these harmful contaminants are proven to cause feminization of male fish, along with lethargic activity and a small appetite for all fish species. In drinking water, a long-term overexposure can be created by these drugs. Although there are not many dangers known for pharmaceuticals being found in drinking water, studies are being done to see if they have a greater effect on pregnant women, people with allergies, and children. Next, Sam will show how pharmaceuticals get into the environment.
Thanks, Maria. Now, as we discuss the dangers of pharmaceutical drugs, it is important that we learn how to prevent these drugs from getting into the environment. One common way these pharmaceuticals end up in the environment is through bodily excretion, caused by drugs being left undigested. Other improper methods are residue from manufacturers and flushing pills down the toilet. They can also end up in the environment through disposing of garbage cans. These are all common ways drugs get in the environment. Here's Dr. Bennett explaining how drugs don't degrade under normal environmental conditions.
Hi, Grady Bennett here, MD, DD, PhD, and the OG. You may be asking yourself, so what happens to the drugs left in our environment? Do they ever go away? Well, we were actually wondering the same thing and did a little experimenting. For our experiment, we took a look at caffeine, a very common drug that shares similar organic structures as many other pharmaceutical products. So using UV vis spectroscopy, we measured the absorbance of caffeine samples starting at 1 × 10⁻⁵ molar over time. Under standard environmental water conditions of room temperature and a pH of 7, the absorbance did not change as time elapsed. Therefore, the concentration did not change, and the caffeine stayed. So basically, a majority of the time, drugs will stay where they are in our environment. What about extreme cases? Well, we also checked those. Under very acidic conditions, still no results. High temperatures, no results. The only results came at extremely basic environmental conditions. At a pH of 13, we finally saw something happen and some of the caffeine dissipated. Unfortunately, if the pH of water is that high, fish have a lot more problems besides caffeine to worry about. So remember folks, dispose of your pharmaceuticals properly because they will not go away on their own. Go dogs.